Alright, hello ladies and gentlemen, we meet again. Vandaag I want us to look at this one, which was written on the 12th August 2021, August Engineering Drawing N2. So I want us to look at question 4, which is this one, isometric question 4. These are the views. I want us to look at this one. So it is very much important to go through the question before you even start to draw. So it reads as follows. Figure 4 below shows 3 views of a casting drawn in third angle orthographic projection. So in most of the time they are given in first. Okay, draw to a scale 1:1. We know what is the meaning of that. An isometric view of this casting. Do not redraw the given views. I like that, because especially when they are given into 2, you'll see a student just drawing the missing view, thinking it's orthographic projection, grade 10 orthographic projection, whereby they'll be saying draw the missing view. This is not grade 10, it's actually grade equivalent to what? To grade 11. So that is why they emphasize for you, do not redraw the given views. Point P must be the lowest point, which means below point P you are not expected to get any point there. Now hidden details, it is required. You are not necessary to show the hidden details. So let's start. So me, when I teach or when I draw the isometric, I'll firstly start with the horizontal line like this, out of dimension like this. Then at this point I'll decide to draw the perpendicular line against this one. So there you go. Where they are perpendicular to each other, I am going to mark that point which they are talking about. Point P must be the lowest point. So that's the point P. Then from point P, you throw away this one, isn't it? The 45 degrees set square, you throw away as if you'll never need it again. You take this one. Where is it? Oh, it's down there. So I'll draw open at 60 degrees clockwise. So there you go. Then 60 degrees anti-clockwise and angle 60 degrees clockwise, like this. There you go. Now together, after I've drawn them like this. So this is what this is. These are the views. I will come back to analyze these views now. So these views are given in third angle orthographic projection. So this is my front view, this is my right view, this is the top view. So which means I will have to force this shape to come there by my left hand side, and this shape there by my right hand side. So what separates right from left is the vertical line. So which means, in other words, this side I'm going to have a right view, this side a front view. All together, assuming these views were given in first angle orthographic projection. In first angle orthographic projection, we're going to have the front view and the left view. This top was going to be below to your front view. Then when it comes to your drawing now, this front view was going to be on your right hand side, so that the left view comes to on its left hand side. All together. So once you understand that, I am going to force myself to get a shape like this way at this portion, because it's front view supposed to be, and this is right view supposed to be on my right hand side. So I'll have to force myself to get this shape at this portion. Okay, right. So from point P, this P is now this one, isn't it? So from point P to move from here till here, I see a dimension of what? It seems to be not given, but for the fact that I understand the law of orthographic projection, it says the front view as well as the top view, they will always share the same what length. The front view as well as the left view or the right view, they will always share the same height, which means from here till there, if it's 40, is the same 40, because this is front, this is right. And the right view or the left view, they will always share the same width with what? With top. From here till there it's 50, which means it's the same as from here till here, 50. That is why 20 plus 10 plus 20, it will give you the what? The very same 50, which means they were not even supposed to dimension this one for you. How to get that? So now let's start. From point P coming this side, I see a dimension of 60 millimeter. Take a 30 millimeter ruler, 60. Is 60. This is 90. This is 60. From here till there, I can draw it solid without fear or favor. I can see what is solid. It's solid from here till there. So when I'm standing here, it's good as if I'm at this point. Now I see an upgoing line, which is what? Which is the height of 40 millimeter. So I cannot just say, oh, it's 40, then from the middle of nowhere I just record 40 like this. I'll be out of order. I firstly have to get a constructional line first, faint like this. Then from a well recorded line, I can record a dimension of what? Of the height 40 millimeter. So there it is, and I can draw it dark again without fear or favor. Why? Because I can see it clearly that it is dark. You understand? So right from there, it's good as if I'm at this point now, which is that one. Now go back to what? To your point P. Move from here till there. From here till there, with what? Height of 10 millimeter. So from here to right there is 10 millimeter. So once I've gotten my 10 millimeter, take it at an angle of 30 degrees clockwise, faint for now. There you go. Right. Now what is going to happen? So now from this point coming this side, I'm going to record what? Because this line is good as if it's going through like this. You understand? So if I'm pointing from here till there, in our correction, it's good as if I'm pointing from here till there. You understand? So we are told from here till there is a march. It's 20 millimeter. Simple, eh? So there is my 20. Do I have to draw it? No, I am not going to draw. The line that I'm going to draw is only this one. But from here till there, I want to draw it. As much as I do not see any solid line there. You understand? So from here, going up there, I'll just connect them like this. All together. So now I can erase this one. I don't need it anymore. This one, I don't need this line anymore. So this shape that I see is this one, and I see it there by my what? My front view. So that is why I will have to what? To force to have what? This one. And bear in mind to say, what is happening with this one? What is this one? Because if you are not careful, you'll be now saying, okay, at this point I see an upgoing line, which means even here I have to what? So correspond with them with what? With the other view. To say, okay, if it's like this in my front view, let me check it nicely there by my top view. What is it happening? Luckily enough, we are given even the right view, because sometimes they will give you the right and they'll give you the front and the right, or the front and the top. So yeah, we're actually given everything. Right, then from there, okay, what is happening now? Do I have to construct this one right from here going up? Okay, I seems to be a bit stuck. I leave that point, I come, and then I'll be like, let me see what is going to happen if I do like this. Let me see what is going to happen if I do like this. And the moment I'm constructing this point, which means now I'm approaching what? I'm approaching to draw the right view. The dimension that now I'll be dealing with are actually from, just zoom it a little bit, yes, actually from the right view, which is what? Which is this one. Okay, from point P, because there by your right view, the P, it will be right there, not R, P. From here till there is 50 millimeter. Okay. And even here, I can just zoom it a little bit. So where 50 is right here, so divide by 2, how much are you getting? 25, eh? And again, do I have to draw it dark? Okay, do I have, as much as I see it dark right from here till there, do I have to draw it dark from here till there? No. Who's telling me that is what is the top view? Okay, I cannot just draw it dark throughout. Okay, what I can do now is this. For now, this one, for the fact that I am 100% sure which is going to be dark, I can draw it dark till right there. And even this one, from here till right there, I can draw it dark as well. Then from there, let's see what is going to happen now. So now I can go up. Do I have to go up like this? And something that will be parallel to this one. I go back to my question and analyze these views properly. Okay, why do I have to see this one solid, whereas I have this one solid again? This one is, why is it solid? And remember, what is this? This is the front view, which means if I'll look at this front view on my, this front view on its top, I am going to see something of this nature. So which means I can say this pattern is this one. Remember that this, it has been viewed orthographically. You are not going to say, oh, this one is a little bit back, this one is up front. It will, everything, it will come to flash as if this point you're supposed to draw it right from here. You understand? So this one is this, and this one is that one at the back. You understand? So which means right here I have to go up. I'll go up. There you go, up till way. Up till way. And to get that, it's going to be simple. So what you did here from here till there is 50, you can do it right there as well. So 50 millimeter. Do I have to draw it dark? From here till here, do I have to draw it dark? No, you can't. Double check your right view. It's a gap. Okay, which means this one, like as I've set it right from the top. So this one is that one, which is this one. So this one is this one, which is that one. You understand? So now everything is clear. So from here till there is 50 millimeter. So where 50 ends, I can now go back. I can now have this line, even dark now, from there till there. You understand? Dark. So I can come back here and have this one dark as well. From here to right there. Then project this point just a little bit. Come this side. That will be parallel to this one. So it's good as if I'm moving from this point to get this one. Thereby my right view. Thereby your top view is good as if you're moving from here till there. Not here till there, because this one, it is it will be the one just that is at a little bit back. But I'm moving from here till there, which is a march. The set is 20 millimeter from here to here. You understand? So I can record that 20 millimeter. I can draw it. Whereas I'm recording, I can draw. Remember, the biggest enemy in the examination center is what is time. So you have to try by all means to what, to save time. Whatever whatever a minute that you might be losing, it will affect you. Okay, so there is my 20 millimeter. So now I can go down till there vertically, from here till down here, and from there till right there, as much as I can see it there by my top view, from here till there, isn't it? So which means even here I'll get it straight away without fear or favor. There you go. So I can draw this one solid. Simple, eh? So again, from here till there, the set is 20 millimeter, isn't it? Which is this one. From there till there is 20 millimeter. So that the 10, it will automatically come out for itself. So there is my 20. I can draw it as well. So there is my 20 millimeter. What I did there, I can also do it down here. So there is my 20 ending here till there. So now you can take your 30 millimeter ruler and you join this 2 point from here till right there. Simple, eh? So now we are going to have a line that's going to be vertical. Actually, everyone was supposed to at least reach this extent during that time, because this is actually grade 10 stuff. So there you go, you stop here. Understand? So you're gonna take this point at an angle of 30 degrees clockwise as well. So from here, once you touch there, you can stop, because continuing is gonna appear as a hidden detail, which the question set do not show them. So I'll come back to have this one solid. You understand? So at least everyone would have collected the marks till such an extent. You understand? So now here comes what seems to challenge isometric cycle. And this isometric cycle, you have to draw it a half of it. So from here till here is 26 millimeter. 26 divided by 2, how much are you getting? TikTok guys, can you divide that one for me? Take your drawing compass. So 26 divided by 2, you are getting 13, eh? So open your drawing compass to 13 millimeter. So thank you very much guys. That yes, it's 13 millimeter. So you place it at 0. There is 10, 13. You have to be accurate. There is 13 millimeter. Yes. So now, or before I do that, I have to get the center, isn't it? So this is the center that we got it. So project it up, because we actually want to draw this isometric cycle on the upper one. Then we project the points vertically down. So the center. So I am not going to. I'll just project the center. I am not going to draw. There it is. Other than drawing like this, understand? That is the center. So now I can take the center at an angle of 30 clockwise. There you go. I can draw it here, this side as well. So this is it. So now we said this is 13 millimeter, isn't it? So now I come and place it here. I mark here 13 and I mark here. We are creating a square of 26. So I've got this center point like this one. Then from there, what can I do? I'll have to get what a faint line that's gonna behave like this and flash it even to this point, because they must be parallel, isn't it? So try to be accurate, especially at this point, because if you are going to draw a point which is right next to or close by, when you are now constructing your cycle, you'll find that they won't be closing because of where now you're missing. So you see, now I want to draw a line that will be passing this point, so I have to be accurate there. So not something close by, but it's supposed to be on top. Try by all means to be accurate. So like this, then from there I come to this one. So from here till there I can stop now, because of I know what yeah, you have to be accurate. Even this one from here till there. So now do you see that I have a square? Let me erase this one before it confuses me. Which one was this one? Is the bottom one, isn't it? This one, erase it. So now I have a square of 1, 2, 3, 4. Do you see? So of 1, 2, 3, 4. I can even decide to put my 1 here, and 2 here, 3 here, and 4 there. So as long as your numbering is consistently, it's supposed to be consistently. If you decide to use Roman figures, they must be consistently. You decide to use alphabetic, they must be consistent. Capital letters, alphabetic, capital letter, they have to be in a format. So I have a point 1, 2, 3, 4. It's a square. We all know square, it's saving what? 4 corners. The only difference is that this square is at an angle of 30. Okay, set it like this, 30 degrees, at an angle of 30 degrees. Okay, so now I'll decide to name this point R, stand for the reference of all the points that I'm about to get now all together. So between point 1 and 2 I have a center point, and point 2 and 3 I have a center point, point 3 and 4 I have a center point, point 4 back to point 1 I have another center. So I'll decide to name this one a small letter A, a small letter B, C, and a D. So in other words, the small letter alphabetic points, they are centers. So the numbering points, they are corners. You understand? So the binary method, it says join the two longest opposite corner, and those corner, remember corner, this is a corner, this is a corner, this is a corner, this is a corner. So point 4 and 2, of course they are opposite to each other, but they are not far away compared to point 1 and point 3 altogether. Point 1 and point 2, they are not opposite to each other, they are in the same line. Point 2 and 3, they cannot say they're opposite to each other, they're in the same line. Point 4 and 3, they're the same line. Point 4 back to point 1, they're in the same line. So they join the two longest opposite points, which is point 1 and point 3. And when you're joining them, this line of yours is supposed to pass point R. You see, it's passing point R, and you do that faint, you draw them faint, It's supposed to be faint. Okay, so now we are going to join the corner to center, center to corner. So we are going to join a corner to center, center to corner. So we are going to join point 4 with point A, point C with point 2. So like this. You have to be accurate. There we go. We've joined a corner to center, center to corner. And these two lines, they must be parallel to each other. You understand? So the time we joined the corner to center, center to corner, our longest 2 points line, it was cut. So that gave us what? A point right there and a point right there. So which I can name it as Roman figure 1 and Roman figure 2. Okay. So remember that, what are we looking for? We are looking for something of this nature, this curve. So it's supposed to be a half. even though you have when you are creating this square, so you have to accommodate all the points, even though some of them at the end of the day you are not going to need them, but they have to be there. So now in order for me to get this one from here till there, so which means I must place my drawing compass at from in figure 1, further extend to point A. This is it. Then before I draw, I have to check, do I need to have some little bit of adjustment? And what can cause that? What can cause that you have to adjust is your point that you are not getting exact point right from your creation of your square. You understand? Because it's supposed to tally. So A to D. So do you see that I have to adjust that just a little bit? So which means I have to go back a little bit. So from here till there you go. So what can cause this? It's a lack of accuracy. It's a lack of accuracy. If you keep on missing dimension, miss right from the beginning, at the end it will be very because 2 points, they will affect the third point, and the wrong of these 3 points, they will affect the fourth point. At the end of the day, your drawing is skewed. You understand? So now to get this other side, I have to use point 4 with A and what and B. So A to B. So now there you go, dark. So this one is correct. You understand? So once I have this, so now from here till there, I will have to have it. It's good as if now I'm having this, isn't it? So do you see that now from here till here, I have a straight line, I have a straight line. You understand? So which means I can come back here and have this one dark from here till there, and from here to right there. You understand? So that's where the trick of this question was actually. So the rest of the other score points, which were just corner, they were just simple and straightforward. So the trick of this was actually here. So now it's good as if this point, it should be this one there by our right view. This one, it should be that one. Do you see that now? I see a vertical dark line, so which means I'll construct this one vertically. Simple, eh? So from here till down here, then push it till where? Till right here. So remember, we erased here, so I must come back to it to get it nicely. So dark from here till right here, then from here to right here. You understand? So now I can come back to it to draw this one dark. Yes, so if you have drew it like this, is it complete? We're done, right? Yeah, my brother owner, long time. Where have you been? Or I'm the one supposed to say where do I actually come from? Long time. So is it done like this? No, it is not done. We still have to get another shape that will be. So we have to draw a parallel arc. The way you draw this arc, we are going to draw another one that will be like this. So the same way we draw this arc, so we are going to project those points. So the very first point that we have to project, remember this arc started from here till there. So which means take this point vertically down, and where were you placing your drawing compass? Here, isn't it? So take this point vertically down as well. So which is this one? It goes vertically down, faint, eh? In this one, faint. Right. So now I will come to record to say, okay, where was I placing my drawing compass the time I draw this arc? I place it here, right here, from here till there, isn't it? Like this. So without disturbing your drawing compass, you will be placing it along this line, or from point 4 going down, you can record a dimension of 10 millimeters from here till there. 10 millimeter, so that you know exactly where are you going to place your drawing compass. 10 millimeter is right here, and you place the drawing compass at 0.4 to B, isn't it? There you go, like this. There you go, which means you'll have to come and place it right here, further extended to this point. So which means I can go back just a little bit from here till right here, dark. So I cannot further draw it till here. Why? Because of the time I drew this one, it started from here till there. So that is why even here it will start from here till there. So just to close it a little bit, it should be the parallel arc, the way you draw this one. How did you draw this one? You place your drawing compass here, isn't it? Further extended to point A. So this is the same point that you are going to take it dark. I mean, take it vertically. With this one vertically down. Now I come back and record that. Okay, I was placing my drawing compass the time I draw this arc. Why am I doing that? Because I want to close. It's supposed to be closed like this, understand? So I place my drawing compass here, further extended to point A. Okay, open just a little bit. I draw it like this. So now I come and place it along this arc. You can still record the 10 millimeter from here to where you'll be placing it, your drawing compass, so that you get that smaller nyana. So is it done? Let me down there on the government. Is it done? Oh no, you said no, you were not done. So is it done now? So he's saying angithi so shintshe igama. Yeah, but actually I was not around. So I think as far as I'm concerned, it's done. So YouTube guys, thank you for watching. That was Mr. Nkosi. See you on the next video. That was engineering drawing of this previous question paper. Remember, our aim is to upload all of them. If you scroll down, you'll see now there is a certain format. If it's a sectional drawing in first angle orthographic, all those videos they'll be just following each other. But if it's what interpenetration, whatever question concerning interpenetration we attend. So like now these days we're busy with this one. I think this one it's the last one as far as I'm concerned. So thank you very much guys for watching. That was Mr. Nkosi. See you on the next video. Please don't forget to subscribe for more videos to be uploaded in this channel. And your comment, they are also important in collection guys, and we would like to appreciate your watching, spending your time watching us. And we've seen some different, a very huge difference in our accounts. So those differences are being caused by you guys, because of you are watching us. So we would like to appreciate you so much. So keep on watching us and let us improve if it's possible. So I would like to appreciate. Thank you very much. See you on the next video. Let me not talk much.